Hi everyone, my name is Yogendra Syal. This is SIT718. In this particular project, we are doing a data analysis on red wine dataset. The dataset contains 159 red wine samples in the north of Portugal and contains 5 variables: citric acid, chlorides, total sulfur dioxide, pH, alcohol, and a target variable which is the quality. Firstly, we are doing data pre-processing in which we are applying different sort of transformation to analyze the dataset. Secondly, we are doing EDA in which we are plotting scatter plot and histograms. Lastly, we are doing modeling in which we are using different sort of models to predict the results. Firstly, we can see in the scatter plot there's no solid relationship in our data. For example, there's no increasing or decreasing behavior between our features and a target variable, which is the quality. So to analyze the data in depth, we are using Pearson coefficient correlation and Minkowski distance. So my friends, you need to see the logic here. If the distance is more, the correlation will be less. If the correlation is more, the distance will be less. For example, in alcohol versus the quality score, the Pearson correlation is very high and the distance is very low. So these two metrics can help us to understand the data better. And even in the histograms, we can see that the pH level is Gaussian distributed, and the alcohol is some sort of Gaussian distributed, but I'll say it is Pareto distributed. So this distribution properties is very helpful to analyze the data. And again, we are also using the skewness. Skewness tells us the measure of the tailness in the data set. As we can see, the citric acid, the skewness 0.4, which is a right tail distribution, and the same with the other features. My friends, choosing the correct variable is very important in our data analysis because we need a stable and a very, very good feature to make the predictions. Okay, for example, if the feature is Gaussian distributed, it is very, very stable and good feature in the modeling. So again, to make the data normal distributed, we are using different sort of transformation, and again, such as log, square root, and we are also normalizing the result using min, max, and z-score scaling. And as we can see that after applying the transformation, or data or the features got some sort of normal distributed. For example, the pH is well normal distributed. The total sulfuric dioxide is also normal distributed. And again, if the data is Pareto distributed, we can use box transformation and log transformation. Again, we can use this sort of transformation to make the data normal distributed. So after making the data normally distributed, we are seeing just like before and after results. So again, we can see after applying the transformation, our data got well stable. And again, after applying the transformation, we are using different sort of models to see the results. And out of like all the models, we can see the QAM with p-value of 2 contains less RMSE and high correlation. We rejected OWA because there's very less correlation compared to the p-value of 2 of QAM. So again, we selected these weights as these are the best weights for our data set, and we are using these weights to predict the results. So my friend, it is very, very important to select the correct variable, and the correct variable and the ideal variable is which is stable and Gaussian distributed. So again, we are using QM model and fitting the model using the best weight, and this is the particular code which we use to fit the model. And again, understanding the model error, we used RMSE, we added root in mean square error to scale down the results. And again, we are also using average absolute error, Pearson correlation, Spearman correlation. These are different metrics which help us to understand the model better. So again, prediction of the results, we are predicting the results using the QM model, and we can see the quality score is close to 7, which is like ideal score for our wines. Again, the condition for higher quality wine is again if the pH value is between 0.3 and 0.4, our results are better, and if the alcohol content is 0.5 to 0.7, our results are good, and our model is very, very good. Again, the limitation in our data set is we don't know the winemaking process. We don't know the quality of the ingredient used in the winemaking process. So again, these are the limitation in the data set which we need to be like considerate about while making the data analysis.